equation, graphing, solving systems by graphing? Or 5. Okay. This is on the back of the first page. So with number 5, we need to solve both of these, get them both in slope-intercept form, and then graph them both, and then see where they intersect, if they intersect. So I'm going to do this simultaneously. Subtract 5x and 3x. We get negative 2y equals negative 5x plus 8, and 2y equals negative 3x plus 8. Then for the first equation, we can divide everything by negative 2. And the second one, we can divide everything by 2. So that first equation would be y equals positive 5 over 2x minus 4. The second one, y equals negative 3 over 2x plus 4. And then we could graph both. Looking at just the equations themselves, they're not parallel, they're not the same, so they're going to cross somewhere and have one solution. So I'm going to start with the first one. Start at negative 4. My slope is positive 5 over 2, so I can go up 5, to the right 2. The other one would be kind of off. And then draw a line through all of those points. Make sure you have arrows at the ends. The other one would start at positive 4. The slope is negative 3 over 2, so we can go down 3 to the right 2 as many times as possible. And connect all those points. And you should be able to see where they cross. And write that as an ordered pair. Questions on that one or any other graphing questions before we move on?
Questions?
I'm going to say that 6 is going to be very similar to this, so let's choose a different one. In this section. This 10 is in the next section. So I know 2 is parallel, and I want to say so is 4, so we can do either of those 2. If we have questions about them. So again, solve both equations, get rid of 8x. And then divide everything by 3. So that the first equation is y equals negative 8 over 3x plus 4. And the second one is y equals negative 8 over 3x minus 3. Just looking at the 2 equations themselves, I see that we have the same slope, but different y-intercepts. So those are going to be parallel lines that give us no solution. You still have to graph it. So the first one would start at positive 4, go down 8, to the right 3. Connect those points. The second one would start at negative 3. So this one we're going to go up 8 and to the left 3 and connect those points. My lines are a little crooked, but they should be parallel lines. They're never going to cross, so their solution is no solution. If you had the exact same equation and they graphed on top of each other, that would be infinitely many. And remember that you could show that by graphing one line and drawing double arrows, highlighting over that line, or drawing another line on top of that line. Questions on how to solve systems by graphing? Go into the substitution. What questions do you have there? We can do 10. I did. We said that earlier. Any others? We'll do those three. So with 7, if you see a variable that's by itself, start with that one. So this y in the first equation, get that y by itself by solving, getting rid of x, subtracting it. It does not matter here if you put it in slope-intercept form or not. Once you have that variable by itself, take the expression, so negative 3 minus 3x, put it back into the other one where y is. So 6x plus 2 times negative 3 minus 3x equals negative 2. Distribute, combine like terms, solve for x. What happens when we combine like terms? They cancel out. So we have just negative 6 equals negative 2, which would be 3. What type of solution? No solution. Because your variables canceled and they're not the same number. Questions on that one before we do 10? Very rarely do you get something like 10 where you don't have a variable that's by itself, which means you have to pick a variable from one of the equations. It doesn't matter which one. You have to solve for it. You're going to have fractions, and you just have to deal with that. So which variable in which equation do we want to solve for? There. Y and which equation? First or the second? The first. Okay. So we're solving for y in the first. We got to get rid of 3x. So we have 5y equals negative 3x minus 13. Divide everything by 5. Now, depending on what variable you solve for, if you have nice decimals, you can leave them as decimals. Like this one will give you nice decimals, 0.6 and negative 2.6. So if you want to change this one to decimals, you can. But if you were dividing, if you would solve for x and we're dividing everything by 3, you would leave those as fractions because you have repeating decimals. I'm going to change these to decimals, but if you want to leave them as fractions, that's also fine. Just like before, take that expression, put it in where y is of the other equation. We have negative 6x minus 10 times negative 0.6x minus 2.6 equals 26. Distribute, combine the terms, solve for x. What did we get here? What happens to your variables? They cancel. Leaving 26 equals 26, which is what type of solution? What would the solution be?
One.
You're on a variable, so it's not one solution. Many, because our variable canceled and they're the same. Questions on that before we do 14? Basically half of it is already solved for you. You know what y is. So we're going to substitute that in to figure out what x is. So I subtract 2 and divide both sides by -1. X is 8. And then when we write our order pair, we already have y, so we would just write 8, -2. So we don't have to solve anything again. We already have y. We just had to find x. One solution, 8, -2. Elimination problems. What elimination problems do we have? Questions. We'll start with that one. With elimination, remember that you're trying to get, if they're not already, the coefficients to be the same. So you need to figure out, are we eliminating x or y? It does not matter. Which one do we want to eliminate?
X.
Okay. So then, in order to make these the same, I have to multiply them both by something. What could I multiply the first one by to make them the same? Sure. If you're not sure, always just multiply them by each other. So the first one by 10, the second one by 7. If you want to change the sign, you can multiply it by a negative whatever number, but you don't have to do that. You have -70x minus 70y equals 0, and -70x minus 70y equals 0. So bells should be going off, light bulbs should be going off, because these look identical. So that should tell you it's going to be a specific type of solution. To eliminate our x's, would we add or subtract? If they're the same, you have to subtract. If you're not sure, double check. Because if we added, they wouldn't get 0. But when we subtract, these both become 0, which is what type of solution? Most of these questions are similar where you either have to multiply one or both to get them to be the same. Did we have any other general elimination questions before we move on to word problems? Okay, questions on word problems? So 25 is not a real word problem because it's just telling you what to do, but we can set this up and solve it, and then we won't solve any others, but we could set any others up so you can see what it would look like. So I'm going to read and highlight this at the same time. 5 times Jasmine's number minus 3 times Josh's number is equal to negative 16. It's also true that 4 times Jasmine's number plus 5 times Josh's number is equal to negative 35. What is the value of Jasmine and Josh's numbers? So the question will help us define 2 variables. They just have to be different. So I'm going to call one J, one uppercase J, and one lowercase j. That would work. For Jasmine's number and Josh's number. Make sure you are defining your variables for every word problem. This I can write just as what it says. So 5 times Jasmine's number minus 3 times Josh's number is equal to negative 16. And then 4 times Jasmine's number plus 5 times Josh's number is equal to negative 35. So it tells you exactly what to do. Then you can solve by using substitution or elimination. Elimination would probably be best here. We have to find both, so it doesn't matter which one we eliminate first. Let's say we were getting rid of the lowercase j. We would need to multiply the first one by 5 and the second one by 3 to get 25 uppercase j minus 15 lowercase j equals negative 80. Is that right? Double check that last one. Are those 2 numbers correct? Yes. So to eliminate our lowercase j's, we would add these because they're opposite. It's really big, I don't know this. We have 37j, uppercase j, plus 0 equals negative 185. And if we divide both sides, what would uppercase j be? Negative 5. The unit here, we wouldn't really have one. You put units if you want, but that's fine. And then we could put this back into one of our 4 equations to find Josh's number. So I'm just going to use the first one. So negative 25 minus 3j equals negative 16. so that Josh's number would be remember that you can always go back and double check yourself, put what you get into both original equations and see do they equal the same, the number that it equals. If it works for both, that's your solution. Are there any other problems we want to see set up? We won't have time to solve completely. I will say that 26 and 24 will be set up similarly where you have 6 numbers. Are there questions in general?
26.
We'll set it up, but not solve. 26 has a lot of extra stuff. Really, the important stuff for this is the number of times on the water side, the number of times on the Ferris wheel, the totals, and the 2 questions. So this part, everything else is really irrelevant. We have our 2 questions. That's going to be your 2 variables. I'm going to call that F and W. For the cost to ride the Ferris wheel and the cost to slide down the water slide. And since we have 6 numbers, you're going to set it up just like we did for 25. Each number will get used. Water slide goes with W, so 3W plus 3F equals 1770. And then the other one would be 2W plus 3F equals 1555. And you could solve by substitution or elimination. Any other setups we want to see really quickly? Okay.
Number 20.
20, which one?
24.
24 is going to be the same setup, so let's not do that one. We can do 23 if you have a question about that one. So in 23, tickets to a school play cost $5 for general admission, $3.50 with a student ID. On opening night, 400 tickets were sold for a total of $15.80. And we are asked how many general admin tickets were sold and how many student tickets were sold. So your 2 questions define your 2 variables. So let's call it G and S. For number of general admin tickets and number of student tickets. When you're only given 4 numbers, 3 of them go together. The other one's going to be used in another one. So we have $5 and $3.50 and $1,580. So those 3, since they're all money related, are going to go together. 5G plus 350S equals 1580. So the 3 things that are related go together. The second total is going to be for the second equation. You cannot use the numbers again, and the equation would just be your 2 variables, G and S. And then you could solve by substitution or elimination. we have any general questions before we start the quiz? Alright, you guys are going to start the non-calculator part, the graphing. When you finish, you can turn that into the bin and then come grab the calculator part. So go ahead and put your calculators up behind your phone.